work through an example problem of the Doppler effect for electromagnetic waves. So the scenario we're considering, there's a car traveling about 100 miles per hour, so 48 meters per second, towards a stationary police car. The police officer's radar gun emits electromagnetic waves with a frequency of 7.5 gigahertz. And there are two Doppler shifts that happen. First, we have the car moving into the police officer's radio waves. So we need to find what frequency would the speeding car detect. That is then the frequency that the car reflects electromagnetic waves at. And then we need to calculate the second Doppler shift, which will tell us what frequency is the police officer going to detect for those reflected waves. So, a few things to note. 48 meters per second is really small compared to the speed of light. So we're going to be fine using the non-relativistic approximation for the Doppler shift. And also, the speeding car is approaching the police car. So our velocity is positive by convention. All right, so let's draw a little cartoon for the first Doppler shift so we can address what frequency is that speeding car going to reflect. So I have our observer and our source of electromagnetic waves. The observer is the speeding car, and the source is coming from the police car. And the electromagnetic waves are propagating from right to left, and the speeding car has a velocity into those waves. So for this first Doppler shift, the observed frequency is going to equal the source frequency times 1 plus the relative velocity over the speed of light. So that's 7.5 gigahertz. And then this term is going to be 1 plus 48, and it's meters per second with the speed of light, 3 times 10 to the 8th meters per second. And that term is 1.1, 2, 3, 4, 5, 6, 1, 6. All right, so that is the slightly higher frequency that the speeding car is going to reflect electromagnetic waves at. And now we need to address the second part, which is what frequency is the police car going to detect. So what frequency does the police officer detect? All right, and so now the roles of source and observer have flipped. And we have a speeding car, and the police officer is with the police car, and we're looking at the waves reflected from the speeding car and propagating towards the police officer. And there's our velocity. Okay. the observed frequency, it's going to be the frequency at the source, 1 plus VREL over C. Frequency at the source is this already Doppler shifted frequency. So this is our F1, and we're going to have two terms, 1 plus VREL over C times 1 plus VREL over C. So we have this term in parentheses squared. Okay. So what the police officer is going to observe is approximately or 7.5 gigahertz, and we're going to have 1 plus 2 VREL over C. And for this, neglecting the term VREL over C quantity squared. So neglecting that quadratic term. This is going to give us an observed frequency that is going to be just slightly higher than the emitted 7.5 gigahertz. 7.5 gigahertz times twice that, 1.0000003